Thank you to watching Shoaib Views channel, and you are watching Pump and Theer Types Part 2. In this episode, I try to explain pump dynamics, efficiency, and production. Pump dynamics refers to the principles governing how pumps operate, particularly focusing on the movement of fluids through a system. Dynamic pumps, such as centrifugal pumps, rely on fluid velocity and momentum to generate pressure and facilitate fluid flow. On the other hand, positive displacement pumps operate by trapping a fixed volume of fluid and forcing it through the system. Understanding these dynamics is crucial for effective industrial applications and maintenance of pumping systems. In these pictures you can understand the pump head. In first picture, total head vs. discharge and suction head. Total head HT is HT equals HD-HS ... In other pictures you can understand the head with flow and no flow. Pump head refers to the maximum vertical height that a pump can lift a fluid against gravity, essentially measuring its ability to move a given volume of liquid to a higher level, usually expressed in meters or feet of water column. It indicates the pump's power to push fluid against gravitational force and is independent of the type of liquid being pumped as long as its viscosity is similar to water. Key points about pump head. Measurement. Pump head is typically measured in meters or feet, representing the vertical distance the fluid can be lifted. Impact of gravity. The higher the pump head, the greater the ability of the pump to lift fluid against gravity. Fluid independence. For liquids with similar viscosity to water, the pump head remains the same regardless of the specific fluid. Performance curve. A pump's performance curve usually shows the relationship between the flow rate and the pump head. Pump efficiency. Pump efficiency is the ratio of the power a pump outputs to the power it consumes. It's a measure of how well a pump transfers energy from a power source to the fluid it's pumping. Example of pump efficiency curve. Pump efficiency equals Q HP367P2. Q equals flow M3 her. H equals delivery head MP equals density of fluid GGDM3. 367 equals conversion constant. P2 equals power consumption at pump shaft Q. Pros of centrifugal pump. PDP must not be operated against a closed valve on the discharge side because it has no shut-off head like centrifugal pumps. Otherwise, the line bursts or the pump is severely damaged, or both. Displace huge amounts of liquid at a time. IT has a low initial and maintenance cost since all motion is rotary and there are no sensitive parts such as the valves in a plunger pump. Troubleshooting. Pump troubleshooting involves checking for issues with the pump's bearings, overheating, impeller, and more. Common pump issues. Overheating. A restricted flow of liquid into or out of the pump can cause overheating. Worn bearings. Worn bearings can cause increased friction and heat, which can damage other components. Impeller blockage. Debris can clog the impeller, preventing the pump from working properly. Cavitation. Cavitation can occur if the pump isn't properly sized or the suction pressure isn't adequate. Excessive suction lift. The suction level may need to be adjusted. Pump driver overloaded. Impurities in the water can stick to the impeller, overloading the motor. How to troubleshoot a pump. Check for leaks, unusual noises, and excessive vibration. Check the temperature of the bearings. Inspect the gaskets for oil leaks. Clean the pump and surrounding area. Check for foaming or discoloration of the oil. If the pump is hot, wait for it to cool before opening it. Check the suction line for obstructions. Check the impeller for obstructions. Monitor the pump's vibrations for misalignment, imbalance, or worn bearings. Pump protection. Pump protection is a system that monitors and protects pumps from mechanical and electrical failures. It helps prevent costly repairs, downtime, and cleanup. How does pump protection work? Detects abnormalities. Pump protection systems monitor pumps for abnormalities and take corrective action. Alerts operators. Some systems alert operators when abnormalities are detected. Shuts down the pump. Some systems shut down the pump to prevent further damage. What are some types of pump protection? Dry run protection. prevents a pump from running without enough fluid in its casing. Overpressure protection prevents the discharge pressure from exceeding safe levels. Thermal protection prevents pumps from overheating. Cavitation protection prevents vapor bubbles from forming and collapsing in the pump. Vibration protection prevents excessive vibration from mechanical issues. Overload protection prevents the pump from requiring more power than the motor can supply. Flow monitoring detects blockages or reduced flow. Pump speed control prevents the pump from running too fast or too slow. That was the final part of pumps and their types. If you like video, please like and share it. Subscribe and follow my YouTube channel ShowUpViews for more informative videos.